Okay, so here I'm in 3.5, the harder trig equations. And I'm doing the last two, number 15 and 16. So here's number 15. Oh, and they say on the interval 0 to 2 pi. On the interval 0 to 2 pi. Okay, so how do we do it? Well, first we've got to get the sign alone. So let's add the root of 2 to both sides. And we get 2 sine 2x is root 2. And then divide by 2. And this cancels, and we get sine 2x is root 2 over 2. Okay, let's go look for a unit circle to find out where is the sign root 2 over 2. So the sign is root 2 over 2, cosine sine right there, and cosine sine right there. So 3 pi over 4 and pi over 4, the sign is root 2 over 2. So pi over 4 and 3 pi over 4. So we have the sine of 2x is pi over 4, or the sine of 2x is 3 pi over 4. Actually, that should say 2x, right? The angle. We're saying the angle has to be pi over 4 or 3 pi over 4, right? Because the sine of pi over 4 or the sine of 3 pi over 4, either one will equal the root 2 over 2. So that angle, that 2x, needs to be pi over 4, or that angle that's inside the sine needs to be 3 pi over 4. Okay, or any number of extra 2 pi rotations, n plus n, any number of extra 2 pi rotations, because if you add a whole number of 2 pi rotations, you're in the same spot, and the sign of that spot will still be root 2 over 2. Okay, so how do we solve for x there? Divide through by 2, put 2 in that denominator, divide by 2 there. Divide by 2 here, put 2 in that denominator, divide by 2 there. So we get x equals pi over 8 plus n pi, or x equals 3 pi over 8 plus n pi. Okay, so now remember how this works. We start with n equals 0, get our first answer. That's just going to be pi over 8. Then we go n equals 1. That one's going to be x equals pi over 8 plus 1 times pi, right? Plugging in 1 there for n. So to add those together, we need a common denominator. Put it over 1, multiply top and bottom here by 8. So that's going to become, well, I'm running out of room here. X equals pi over 8 plus 8 pi over 8, right? That's just a fancy pi right there. 8 pi over 8 is a fancy way of saying pi, or 1 pi. Add those up, 9 pi over 8, because it's 1 pi over 8 plus 8 pi over 8, 9 pi over 8. So that's our second answer on that side. Remember, for 2x, we have 2 answers on each side. And then we can just look at the jump. How much from pi over 8 to 9 pi over 8? It went up by 8 pi over 8. Okay, so over here now, for n equals 0, we get x is 3 pi over 8 is our first answer. And then the next one, just add, remember what the jump is. 8 pi over 8 is going to be the same jump both sides. So 3 pi over 8, add 8 pi over 8, 11 pi over 8. That's the second answer on that side. So there's our 4 answers. Pi over 8, 3 pi over 8, 9 pi over 8, and 11 pi over 8. There's our 4 answers, 2 on each side, to that equation. Okay, now for number 16. Let's try this one. So for this one, let's go back and let me get the question back here. it is this right there. So I need to solve that question. Let me go back here and write it in. So it is 3 sine x plus 6 root 3 is sine x plus 5 root 3. So the first thing we got to do is get this sine of x alone. Notice it's in two sides. What do you do when the thing you're trying to isolate is on both sides of the equal sign? You get rid of one of them. So minus sine x from both sides, gonzo. 3 sine x minus 1 sine x leaves 2 sine x plus 6 root 3. These cancel. Is 5 root 3. Next, subtract the 6 root 3 from both sides, and we get 2 sine x equals 5 root 3 minus 6 root 3 is minus 1 root 3. Last step to get sine alone, divide by 2. So sine of x is minus root 3 over 2. I should have said on the interval 0 to 2 pi. Okay, so the sine of x we now know is minus root 3 over 2. So this is just a regular x. So let's just go to the unit circle and find out where sine is negative root 3 over 2. We'll go look on the unit circle here. So where is sine negative root 3 over 2? Right here, cosine sine, negative root 3 over 2 at 5 pi over 3, and 4 pi over 3 cosine sine is negative root 3 over 2. 4 pi over 3 and 5 pi over 3. So x is 4 pi over 3 or 5 pi over 3. And we don't have to do anything else because this wasn't like a 2x or a 3x, so we don't have to do the extra cases. And they just wanted 0 to 2 pi, so we don't have to do the plus in 2 pi at all. None of that is needed. That's it.